In this video, we are going to learn about tree diagrams. Here is an example. A couple plans to have 2 children. Each children is equally likely to be a girl or boy, with gender independent of that of the other child. First, construct a sample space for the genders of the 2 children. We are going to use a tree diagram to illustrate the possible outcomes of the 2 children. Step 1. List all possible outcomes for the first triad or child. B stands for boy, G stands for girl. Step 2. Draw a dot to the left of the possible outcomes for the first triad. Then draw lines from that dot to all outcomes for the first triad. Step 3. Add the probabilities to the outcome on the lines and calculate as number of ways to get that particular outcomes divided by total number of outcomes. We have 2 possible outcomes, boy or girl, so that's why the denominator is 2. We have 1 way to get a particular outcome. It is either boy or girl. That's why the numerator is 1 for boy and 1 for girl. Last, you want to check the summation of all brands. That means you add 0.5 with the 0.5 in the second branch. The summation always equal 1. Step 4. List the possible outcomes for second trial based on the outcome of the first trial. Then you repeat steps 2 and 3. Add branches and assign probabilities to each branch. Again, we want to check the summation of the branches. The summation of the branches always equal 1. Note that the gender of the second child is independent of the gender of the first child. For example, given that the first child is a boy, the probability that the second child is boy is still 0.5. Step 5. Create sample space. There are only 4 possible outcomes. The BB stands for first child is a boy, and the second child is boy. BG stands for first child is a boy, second child is a girl, and so on and so forth. Step 6. Calculate the probability of each event in the sample space. The probability of B and B equals 0.5 times 0.5. Probability of B and G equals 0.5 here times the 0.5 on this branch. The probability of G and B equals to the probability of this branch times the probability of this branch. Last, the probability of G and G equals to probability from this branch times the probability from this branch. From tree diagrams, we have the sample space here. There are only 4 possible outcomes in the sample space. Then we can calculate the probability of each outcomes in the sample space. We can verify the axioms or rules of probability. First, we can add these 4 probabilities. The summation of them is 1. Second, each probability is between 0 and 1, and all possibility sum to 1. Then we can answer this question: what is the probability that both children are girls, which is represented by this equation. Answer part B. If in reality, for a given child, the chance of a girl is 0.49. It is the same setup, but now the probability on the branches has changed. The probability that both children are girls is calculated as the product of these numbers, which is 24%, and the probability of the first child being girl and the second child being boy is product of these two numbers, and so on and so forth. What is the probability that the couple will have one girl and one boy? There are actually two ways to get one girl and one boy. The first child being girl and the second child being boy. Or the first child being boy and the second child being girl. So the probability of one boy and one girl should be the summation of this probability and this probability. Last, there is an excellent example in Lab 5. So when you study Lab 5, please pay attention.